Two shapes are said to be similar if one is an enlargement or reduction of the other. In this pentagon, the sides have been coloured different colours, so you can follow the colours as the shape's enlarged. So here the sides have all been doubled. You can see the blue line is 2 diagonal boxes. It has been doubled up to 4 diagonal boxes. That's scale factor 2, the original shape, 2 diagonal boxes, the image under the enlargement, 4 diagonal boxes. Similarly, the red line here, 4 boxes long in the original, the image, 8 boxes long. The red line has been doubled. So the sides have been doubled, but the angles are unchanged. 90 degrees here in this left corner, it's still 90 degrees in the image. In this corner, 135 degrees. In the image, it's still 135 degrees. Top corner here, 90 degrees. It's still 90 degrees in the image. So the angles are unchanged. We say the two shapes are equiangular, and because the sides have all been scaled in the same way, we say the two shapes are similar. So that's a condition for two shapes to be similar. They must be equiangular, the angles are unchanged, and the sides have been scaled by a scale factor. All the sides have been scaled in the same way. Here's scale factor 3. 2 diagonal boxes has become 6 diagonal boxes. 4 boxes here in the red has become 12 boxes on the image. Angles unchanged, 90 degrees at the corner here and here, 135 at this corner, here and here. So two shapes are similar. They are equiangular because the angles are unchanged and the sides have been scaled in the same way. So the two shapes are said to be similar. Similarly, scale factor 4, 2 diagonal boxes has become 8 diagonal boxes. 4 boxes here in the red has become 16 boxes. Angles remain the same. Two shapes are equiangular because the angles are the same. Because the sides have been scaled as well, the two shapes are similar. And that's enlargements. Same applies to reductions. There's the original shape, half all its sides. That's a scale factor of half. 2 diagonal boxes became 1 diagonal box. 4 boxes here on the red became 2 boxes. Angles remain unchanged. Even a scale factor like 1.5 or 1.5, 3/2. 2 boxes became 3 boxes. So notice the scale factor is in the image, that's 3 diagonal boxes over the original 2 diagonal boxes. 3/2, a top heavy fraction, means an enlargement, and 3/2 is the same as 1.5 or 1.5. In other words, if the scale factor is greater than 1, you'll get an enlargement. If the scale factor is a fraction between 0 and 1, like a half, that will cause a reduction. So, angles remain the same, shapes are equiangular, sides have all been scaled, therefore the shapes are similar. So here is an original shape. Supposing I want to apply scale factor 2 to get an image. If I put the grid on, 4 boxes here at the top should become 8 boxes. 4 boxes at the side should become 8 boxes. 2 diagonal boxes here should become 4 diagonal boxes. And there's the image. Equiangular because the angles are unchanged. Sides have all been scaled in the same way. So the shapes are similar. Here we carry out a reduction, 1/2 or 0.5. So we take the original shape, 4 boxes along the top, becomes 2 boxes. 4 boxes down the side becomes 2 boxes. 2 diagonal boxes becomes 1 diagonal box. All the sides get halved. There's the image. It's equiangular because the angles are unchanged. The sides have all been scaled in the same way, so the two shapes are similar. So, in general, an enlargement if the scale factor is greater than 1, a as a fraction, it would be a top-heavy fraction. An improper fraction, number in the top bigger than the number in the bottom. A reduction, if you use a fraction between 0 and 1. So a proper fraction like 2/3 would cause a reduction. Under the enlargement or reduction, the angles are unchanged. We say the shapes are equiangular, but the sides are all scaled by a scale factor. So here it is summarised. Similar shapes are enlargements or reductions of each other. Angles unchanged, so the shapes are said to be equiangular. The sides have all been scaled by scale factor. So here shape 1 is enlarged to shape 2. If I put the grid on, 2 boxes along the top became 3 boxes along the top. So when moving from 1 to 2, 2's the image, 3 boxes, and 1's the original, 2 boxes. The scale factor is image 3 over original 2. It's a top-heavy fraction, an improper fraction. It's an enlargement. If we were moving from 2 back to 1, that is, we're going to reduce 2 back to 1. 3 boxes became 2 boxes. So this is the original shape 2. The image is 1. We put the image size 1 over the original size 2. That means 2 boxes over 3 boxes. Scale factor is 2/3. That's caused the reduction. That's a proper fraction. The number in the top is smaller than the number in the bottom. So scale factor can be found from the shapes by putting the image size, the new size, over the original size. That is the old size. The new size over the old size, or the image over the original. So there's what we have so far, with scale factor being image size over original size. That's the new size over the old size. Now here's an example of equiangular shapes. 90 degrees, 90 degrees, 135 degrees, 135 degrees, 45 degrees in the corner here. The shapes are equiangular, but they are not similar because they've not been scaled. This 1 has doubled up to 2, but 4 here hasn't doubled up to give you 8, it's giving you 6. It's 1.5 times bigger. 4 is 1.5 times bigger to be 6. 1 is twice bigger to get 2. Similarly, 1, 3 times bigger. 4 should become 12, it's 8. Well, that's not right. So these shapes are not scaled, they're not similar, although they are equiangular. Now, here's an example where you'd apply scale factors to similar shapes. So these two shapes are similar. The one on the left has been enlarged to the one on the right. We're trying to find out this edge here, the one with the letter on it. So the one where we're trying to find out the value of the letter we call the image, and the other one's the original. And for the scale factor we put image over original. Well, we know the 6 has turned into that 9. The 9's the image size, 6 is the original size. The scale factor is image over original. It's the 9 over the 6. That fraction will simplify. 9/6 is the same as 3 over 2. Divide the top number by 3 and the bottom number by 3, and you've simplified the fraction. So a fraction 9 over 6, simplify it to 3 over 2. Keep the fractions as simple as possible, and then you won't need a calculator. If you want to work out A, we need to scale that 14 up to become A. So we apply the scale factor. To get A, you take the 14 and you multiply it by the scale factor 3 over 2. Now to multiply by a fraction, divide by the bottom number and multiply by the top number. So 14 divided by 2 is 7, times 3 is 21. A is 21. So there's the stages of the working. Get the scale factor, apply the scale factor. Doesn't require a calculator. Here's another example, this time a reduction. The big arrow has been reduced to the smaller arrow. Smaller arrow has B on it. We're trying to calculate B, so we call that the image, and the other one's the original. The scale factor is image over original. So that 5 turned into that 3. 3 is the image, 5 is the original. So when we want the scale factor image of original, put the 3 over the 5. That doesn't simplify. 3/5 is the scale factor. To get B, you want to scale that 12 using the 3/5. So to get B, take 12 and multiply it by 3/5. That means divide 12 by 5 and multiply by 3. 12 times 3 is 36. You want to divide 36 by 5. Well, 36 divided by 5 is the same as doubling the numbers. 72 divided by 10, which is 7.2. So it didn't require a calculator. You've got knowledge of fractions. So that's scale factors. It doesn't just apply to shapes. Here we've got two jugs. We're told one's an enlargement of the other. In other words, they're similar. So there's a scale factor involved. The letters on the bigger jug here is an enlargement then. The little jug's been enlarged to the big jug. A is what we want to calculate. We make that one the image, the one we're trying to calculate. The other one's the original. 9 on the image came from the 6 on the original. So when you put scale factor, you put image over original, the 9 over the 6, simplify that to 3 over 2. Take 20, apply the scale factor to get A. So there's 20, gets multiplied by the scale factor, 3 over 2. Divide by 2 and multiply by 3. 20 divided by 2 is 10 times 3 is 30, A is 30. So that's an enlargement because we've got a top heavy fraction. It's a fraction bigger than 1 for the scale factor. Scale factor bigger than 1 gives you an enlargement. Here's a reduction. So the big one has been reduced to the wee one. We're trying to figure out B. So B is the image. So here, B is the image. The other one's the original. If you want the scale factor, you put image over original. So you've got to be careful to put the 6 over the 9. That cancels down, simplifies to 2/3. That's a fraction less than 1 because the number at the top is smaller than the number at the bottom. It's a proper fraction. Number between 0 and 1 will cause a reduction. So we now apply the reduction to the 30. The 30 is to be reduced to the 4. So we'll take the 30 and we multiply by the scale factor. You always multiply by the scale factor. You never divide by the scale factor. 30 times 2/3, divide by 3, the bottom number multiplied by 2, the top number, 30 divided by 3 is 10, times 2 is 20. So, here we have B is 20. Now it's a simple set of calculations. Calculate the scale factor from image of original, simplify the fraction, and then multiply by the scale factor to find the image. Now always be careful to pick the correct shape as the image. It's the one with the letter, the one you're trying to find out the value of. So that's similar shapes. There's a worksheet on this. If you go to the link in the description, you can download this booklet, which is lots of exercises on similar shapes. It's got some examples first, where there's a similar shapes length exercise. So you can practice this, and then at the very end of the booklet it has the answers, so you can check the answers. The exercise does not require a calculator. If you simplify the fractions, the calculations are pretty straightforward. Also on the link you can download a set of notes for all the exercises on similar shapes. It summarises all the things you'll need to know through all the videos on similar shapes. Hope you found this video useful. The next video will cover triangles, similar triangles. Thank you.